Golden Iris Productions presents Equivalence of Emergent Gravity, Electrogravitic and Newtonian Formulations by Mark F. Dennis.
Newtonian gravity. We begin with Newton's law of universal gravitation. This equation describes the force between two masses. It follows an inverse square relationship with distance. This simple expression has successfully described gravity for centuries. Here, G is the gravitational constant, which sets the overall strength of gravity. M1 and M2 are the interacting masses, and r is the distance between them. Together, these define the gravitational force. From force to acceleration. Newton's second law tells us that force equals mass times acceleration. This allows us to connect gravitational force to the motion of an object. Applying gravity, we write force as m times g. Setting this equal to the gravitational force, we see that the test mass cancels out. This is a key result. Gravitational acceleration is independent of the test mass. Surface gravity. We arrive at the familiar expression for gravitational acceleration. G equals gm over r squared. This equation describes surface gravity for any massive body. Earth. Let's apply this to Earth. We use the known mass and radius of the planet to compute surface gravity. Substituting the numerical values into the equation for G, we obtain approximately 9.82 meters per second squared. This is the classical Newtonian result.
Emergent gravity formulation. Now we introduce an alternative formulation. Here, gravity is expressed using quantum vacuum constants. These include the Planck length, the fine structure constant, and electromagnetic constants. In this view, gravity emerges from deeper vacuum structure. Electrogravitic formulation. A second alternative describes gravity as arising from changes in vacuum permittivity. The local deviation from the vacuum value produces an effective gravitational acceleration. This connects gravity directly to electromagnetic properties of space. Equivalence at Earth's surface. When evaluated at Earth's surface, all three formulations produce nearly identical results. Newtonian gravity, emergent gravity, and the electrogravitic model all converge to the same value of G. This suggests a deeper underlying equivalence.
Extending to the quantum scale. We now extend the gravitational equation to the quantum scale. The same inverse square structure remains valid, but mass is replaced with an electromagnetic equivalent involving charge and electron mass, and the gravitational constant is replaced with Coulomb's constant. Gravitational constant in EM form. In this framework, the gravitational constant itself can be rewritten in terms of electromagnetic and quantum constants. This removes the need to treat gravity as a separate fundamental interaction. Quantum gravitational acceleration. The resulting expression for acceleration now depends on electron scale quantities. Gravity appears as an emergent effect derived from electromagnetic structure.
Quantum time dilation. Time dilation can also be expressed in this framework. The familiar gravitational form is rewritten using electromagnetic quantities. This transformation is purely algebraic, with no need for space-time curvature or derivatives. Electron radius. We now examine the emergence of the classical electron radius. By setting the time dilation factor to its critical limit, we define a natural boundary. Solving for the radius gives a fundamental scale, where electromagnetic and gravitational effects converge. Constants. To compute this radius, we use known physical constants. These include the vacuum permittivity, the elementary charge, the electron mass, and the speed of light. Electron radius. Substituting these values into the equation yields a radius of approximately 2.8 times 10 to the minus 15 meters. This exactly matches the classical electron radius.
Rewriting the Coulomb constant in terms of vacuum permittivity further reinforces the electromagnetic origin of this result. Conclusion. The equation G equals gm over r squared remains valid from planetary scales down to quantum scales. In this framework, gravity, time dilation, and particle structure all emerge from a unified electromagnetic vacuum. Gravity is not fundamental, but emergent from deeper physical laws.